Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. Hello and welcome. I'm your host, Peter Ballant from Technicon. In this episode, we look at the AQUARIUS project for the first time. AQUARIUS is an EU H2020 project dedicated to clean water. The consortium advances cleaner water by examining new methods of sampling and sensing for contaminants in water that is going back into the earth. Today we speak remotely with Anatol Ehrlich from QuantaRed Technologies in Vienna. They are one of 9 project partners throughout Europe. Thanks for joining us today.
Yeah, thanks for setting it up.
We can see the big picture in AQUARIUS is clean water, but your goals are actually quite specific. What are you trying to do in AQUARIUS?
As you mentioned, the big picture in AQUARIUS is the clean water, and the specific goals are actually how can we monitor to get this clean water. So it's a different concept once you say there's one way to get clean water, which would be hands-on experience. So by developing a process to refine water that is dirty and get it cleaner. And then there's a different approach, which would be monitoring the clean water process. And in the AQUARIUS project, we're talking about the monitoring. So we want to make an analyzer that monitors the quality of the water. And the way we do this is that we develop a spectrometer, a very compact spectrometer, which is also easy to use. And with the spectrometer, we can actually target specific molecules, which give a good indication of whether a process stream or whether water is actually clean or not. And within this project, we, first of all, develop the spectrometer, and second of all, define which molecules are the ones of interest to define which process streams are clean and which are not. Another point is that it also benefits the customers as well. So in this case, for the product that we develop, the customers have an easier product to use with which they can find out whether their process stream is actually clean or not clean.
We've been analyzing water for years. I mean, obviously, because we've been cleaning water for drinking for many, many years. What makes this so different?
The difference is that the product that comes out of the AQUARIUS project should actually replace older products or older instruments that are very, very old, often 30 or 40 years old, based on an old technology, which are, first of all, very bulky, they're very expensive, and often they only get used in specialized laboratories. Just to name 2 common methods, it's GCMS, or gas chromatography, or HPLC, which is high pressure liquid chromatography. These are the two main methods used to determine the quality of water. And with these, it often takes up to a week maybe to get a result. So there's a lot of lag between the time where a customer or a company wants to determine, is my water actually clean right now, to actually getting the result and knowing, okay, it's not clean. And within the AQUARIUS project, we develop a product with which it's a lot faster, a lot easier. You get results within minutes. You do not need to take any sampling, so you don't need specialized personnel to get you the results. It's a plug-and-play system. You set it up, it runs, and it gives you results within a couple of minutes. And that's a lot of time that is actually gained by using the product that comes out of this project.
Well, that's really quite a breakthrough. It seems that with these quick results, it should give the end user the ability to act in a much quicker way to any kind of trouble down the road.
Exactly, yeah. And there's actually 2 different concepts that get mentioned or followed in the industry. So there's one called process monitoring, and there's another one called process control. And the differences are, by process monitoring, as the name already mentions, one monitors the current state of the water right now. So every 10 minutes or every 5 minutes, the user gets informed the water quality is good. It's good, until at some point maybe it gets bad. And once it gets bad, personnel gets informed, and then certain processes can be made in order to counteract the worsening quality. So that was process monitoring. And then the second area where we also want to integrate the device is into the process control, where the information is not only gathered, but it's actually used as a feedback loop. So the information comes from the measuring device, and it automatically already determines, okay, the process quality is lower right now. I need to do this action, like open a valve or close certain openings where the water is coming in from to save, for example, the environment if there was an oil spill that was happening. So those are the two different areas where the analyzer could be used.
Well, it's really quite profound that the work you're doing in Aquarius today could have such huge downstream benefits.
Mm.
And when you work in Aquarius and you design the sensors, who's your end user? Who are you building this for? Or what do you have in mind as you do your research and your development?
Yeah, the two main companies that we target, or the two main areas, are first of all the petrochemical companies. So these would include OMV, Shell, BP, Petrobras, because especially the oil companies, they actually deal with huge amounts of water on a daily basis. So we're talking millions of cubic meters every single day. And they also have extremely varying degrees of cleanliness of the water. And especially for petrochemical companies, it's actually crucial for them to know at which stage of their processes they need to know how clean their water is. So especially for them, we could see a potential of each company or in each site, them using several of our devices because it's set up in different phases. So they start off with extremely dirty water, they go to the next stage and it gets a little bit cleaner, and the next stage cleaner and cleaner and cleaner. And after every single one of these stages, there could be one of our products that continuously monitors how clean their water is right now and whether the processes they're implementing to clean the water are actually working. So that would be the first application case.
Okay.
And then the second application case would be water monitoring facilities. So this would include companies like KWR or any governmental agencies or bodies that simply want to check the water quality of surface water. So river water, lake water, any water that is basically in contact with the environment. And also in this case, we could use the analyzer. You could place it on a river, for example, and it will continuously tell you how clean or dirty the water is with respect to certain parameters that have been defined.
Okay. And is it just about oil in water, or could it be other contaminants as well?
It could actually be other contaminants as well. I mentioned oil and water simply because it's the largest market. And there's a lot of people interested specifically in oil because you've heard about it. The BP oil spill are huge topics that are of interest. But at the same time, it should be noted that other molecules could also be analyzed.
I see.
So, for example, if there is a certain molecule that is of interest, you could also potentially identify it depending on what range the molecule absorbs in. It's not limited to oil.
And so with Aquarius, it's all about the sensing, as we've established. But as I read your webpage for Aquarius, they make a distinction about inline sensing and online sensing. Can you tell us about the difference here?
Yeah, so inline sensing is quite literally what it means. It's you measure within the line, so within the process stream. So if you can imagine that you have a pipeline or a river, an inline sensor would be a sensor that you hold directly into the stream and you measure within the stream. Now, this is in contrast to the online measurement, where a part of the stream, so a part of the river stream or a part of the pipeline stream, is actually withdrawn and then analyzed outside of the stream. And the major difference is that for inline sensing, you have extreme conditions often that take place. So you can imagine a pipeline where there's several thousands of liters that go past a second, high pressures, high temperatures. So these are very extreme conditions. Whereas with the online sensing, you can actually kind of adapt the conditions to benefit yourself or to make sure that your system is working correctly. So the online one is withdrawing and the inline is within.
One of the hopes when working on one of these European Union projects is to have some sort of innovation.
Mm.
I think in Aquarius, there's been a few different innovations. Can you tell us about what kinds of things you've developed?
Yeah, so in general, there's three major innovations. So the first one is the compact spectrometer module that has been developed by Fraunhofer Institute together with Vigo Systems from Poland. And they have developed something very remarkable. So they have actually managed to create a very compact and portable quantum cascade laser, an external quantum cascade laser, which is tunable over a wide range of wave numbers. So a quantum cascade laser can basically be seen as a normal kind of laser, just that it emits in a specific area. And the main advantage is that it has a higher power than different types of lasers within the area of interest. And the huge innovation in this case is that it's a compact module, so you can really carry it in your backpack from one place to another. It's very easy to implement. So within the project timeline, within the project, we have created a plug and play system where you can simply connect the spectrometer and start measuring within a couple of minutes. And of course, there's a wide range of target molecules that can be analyzed using this spectrometer. So that's the first innovation. The second one would be the online analyzer itself. So it would be the first online analyzer which would analyze oil and water content using a extraction method and then measuring in the mid-IR region. The crucial thing about the mid-IR region is that in the mid-IR region, this is where most of the oil molecules absorb. So this is where all of the information you want to gather about an oil process is within the mid-IR region. And this would be the first online analyzer, which could do this with solvents that are not made from CFC. And in our case, we would use a more friendly substance to do the extraction process and then measure in this critical mid-IR range. That would be the second innovation. And the third one would then be the inline analyzer, as we talked about before, where it's called the mesoporous silica layer, is used to trap the target molecules inside of a layer. So it can kind of be seen as a selective sponge that gets held into the water. And instead of absorbing water, it actually only absorbs the molecules you're interested in. And then we can still use the same spectrometer in both cases, the online and the inline. We can use the same light and do the same type of absorption analysis and then determine which molecules or which target analytes are present in the process stream.
And another important part of any good project is the proof of concept or the testing that has to happen. And I know that that's kind of the stage that you're in right now. Are you able to tell us a little bit about how you're testing or where you're testing?
Yeah, sure. So as in the development cycle of any prototype, there is always a first phase where the prototype, once it's been finished and built, it needs to be tested under laboratory conditions. We don't want to throw it right away at the most difficult conditions out there. First of all, we want to determine how it performs if it's given a defined environment to operate in. And this has already been done by KWR, the Water Analysis Institute in the Netherlands. So about a half a year ago, we sent the prototype, the online analyzer, to Utrecht. And they did experiments for several months where critical parameters such as the limit of detection, the measurement range, the repeatability, the response time, all these critical parameters were defined under ideal conditions, so to say. There it performed very well. So we got very good feedback, which we then implemented or we made better, and we made some adaptations. And then we said, okay, now it's been tested in the lab, we can test it in a different environment. And currently, about a month ago, we went to OMV, which is a petrochemical company in Austria. And there we tested under difficult conditions. And this test is actually going on right now. And there we want to also define or find out how good our analyzer performs in such a petrochemical environment where there is a lot higher concentrations, where there is a lot higher temperatures, and the conditions in general are a lot harsher than in the laboratory, of course. And then in the very final phase, to also see how it works for water monitoring, the analyzer will go back again in about 1 month to the Netherlands, to KWR, and they will test it in the field in the River Rhine, where it will be situated next to other analyzers, and it will be taking measurements at the same time as other commercial analyzers, which work in a different way, but the results can be compared. And it will be there for around 2 months. And then once the results are in, we can compare how our analyzer performed to the other ones.
How long does this project go?
In total, it was 3 years.
Are we sort of near the end here?
Yes, so we are towards the end. It did get extended for 1 year in total, in part because of the coronavirus, and we were not able to test it in the field in the Netherlands because their facilities were closed, and the same with OMV. So it had to be extended for 1 year, and it ends at the end of 2020, so in around 3 months.
Okay. And so that would explain why you're at the towards the end of this testing phase as well. But it sounds like that regarding testing, everything is going as planned. Is that right?
Yes. So especially for the online analyzer, we've been very happy. We've got very good feedback from the partners, and also a lot of input from them in ways we can improve the device. So Christoph Puls, for example, from OMV, he's testing it right now, and he always comes up with new ideas. Maybe we can improve this, maybe we can improve this, or he mentions that especially this feature we have is working very well right now. So it's a very, very close collaboration with all the partners, actually.
And your partners are pretty much across Europe, right?
Yes, so they are really across Europe.
That's got to be a little bit difficult working with someone who's not in the office next to you, but in another country, perhaps. Any challenges in that kind of situation?
Yes, of course, always with such projects. But I guess the biggest challenge was at some point you have to make compromises because you can always work forever tirelessly to optimize a process. It's a never-ending process. And especially at the beginning of the project, we found different ways how to approach the online analyzer. We evaluated them, and each one had its own advantages and drawbacks or disadvantages. And basically, we had to come up with a solution where we say, okay, how can we get the best out of all of these methods, combine them into something that is reliable, and then work with that and optimize that process. So I think the biggest encounter or the biggest challenge in that respect was just making that decision and saying, we know this is the best way to do it. It might sound easy to say now, but back then it's a very difficult decision to make.
I can imagine. Yeah, of course. And Anatol, I wanted to ask you at the end of the project, what is success for you? And when I say for you, I mean you or QuantaRed actually also.
I think probably the way I would define success, or what would make me very happy in particular, would be, actually it's not, it would be, it is that I can point to that device and I can say, we worked on this. We as a company, QuantaRed, we worked on this product, and I'm proud to show it to people, to point to them and say, look, this is what happens. This is what comes out if we work hard for 2 years, 3 years. We work together, and nothing makes me more happy than showing this to people and being proud of it.
Yeah, there's got to be an incredible pride that goes along with seeing your product out there in the real world.
Definitely, yeah.
And this is something we'll talk about in our next podcast, actually. We'll kind of look at the stretch from research to the marketplace and kind of see what that's all about. But the first time out, I wanted to just get a little bit of the science background and some explanations of how this works and what the goals are. So thanks for sharing that with us today. And thank you for pushing this project forward. It's an exciting project with some real tangible results that we can see and touch down the road. So thanks for your efforts in AQUARIUS.
Thank you very much for having me.
If you'd like to see more about AQUARIUS, check out their website at aquarius-project.eu. This podcast has been brought to you by Technikon. The project leading to this application has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 731465. This project is an initiative of the Photonics Public-Private Partnership.